In this portion of our training, we'll be discussing downbursts, hail, and flash flooding. A downburst is a severe downdraft of rain-cool air that rapidly descends in a thunderstorm. Here in Illinois, most of our downbursts are considered wet downbursts, which means they have heavy rain with them. They can last for several minutes and be a mile or more wide. When you're out spotting, a rain foot will indicate where the strongest winds are occurring. In this particular example, near El Paso from 2014, you can see the rain foot curling up off of the left side of this picture. Wind speeds in a downburst can reach as high as 100 miles per hour or more. The damage from these type of wind speeds will be the same as what can occur with a weak or even a strong tornado of EF0 to EF2 intensity. Also note that the wind will change direction quickly. Here's a little better example of a rain foot. Here's another example of a downburst. It is descending on the left half of the image. We look a few minutes later, what's left of it is over on the right side. On this particular day, several downbursts did produce wind damage from 60 to 80 mile per hour winds. Many downbursts are from multi-cell cluster type thunderstorms. However, they can also occur with squall lines at the front of the line with the strongest updrafts and in the heavy rain area. In addition, you can also see them with supercells in and near the heaviest rain, also known as the forward flank downdraft, and with the rain-free base with the rear flank downdraft. Looking at how hail forms, rain will be sucked up into the updraft, go above the freezing level where it collects a layer of ice. In the current circulations up above, it'll be brought back down below the freezing level where it picks up another layer of water, comes back up above the freezing level where it refreezes. Their circulation will continue until the hail is finally too large for the cloud and it will fall back to earth. All types of thunderstorms can produce hail. However, the biggest hail is associated with the strongest updrafts, and those are usually with supercells. Supercells can produce hail bigger than a golf ball. In these particular examples, in a hailstorm that affected Tuscola in 2014, hail reached from tennis ball size to as large as 4 inches in diameter. As you can imagine, that size of hail can cause extensive damage and even injuries. This is the radar presentation of the Tuscola hailstorm from last year. Hail is water-covered ice, so it is very reflective on the radar. In the radar images, the areas that are in white and purple are the highest on the radar scale. This is where the hail is occurring. High radar reflectivity values are often associated with hail. When you're out spotting, sometimes you can see a hail shaft. These consist of white streaks off in the distance. Now talking about flash flooding. Flash flooding is a flood where the water rises rapidly. It can occur in any area, especially if the ground is already moist. Usually 1 to 2 inches or more of rain in about an hour's time is a general rule for flash flooding. However, flash flooding can also be caused by a dam or a levee failure. Multi-cell cluster thunderstorms are often the types of storms that will produce flash flooding. They will produce individual storms that move over the same areas for several hours. We refer to these types of cells as training echoes because they will follow one another similar to a train. However, supercells can also produce flash flooding. This would be frequently in the heavy precipitation shield. The way we define flash flooding, at least one of the following must be occurring. Either water is flowing over roads at least 6 inches deep or more. Water may be ponding at least a foot deep, water is flowing over bridges, or there is a rapid rise in creeks or streams to bankful or higher levels.